All right, so this is the rest of the problems from section 3.2. The program crashed on me. I didn't want to erase all this stuff, so I'm just going to go through it real quick. For problem 2a, we were asked to find all values where the function has a discontinuity. So here's the function. We found the discontinuities by setting each part of the denominator equal to 0. So if I set that one equal to 0, I get negative 1/2. Set that equal to 0, I get negative 2. That's the two discontinuities. We're further asked to find the limits. If you graph this function on your calculator or on Desmos, what you'll find is as you approach negative 1/2, it does this sort of thing. On one side it goes up, on the other it goes down. The limit doesn't exist. The same thing's happening at negative 2. On one side it goes up, the other side it goes down. Limit doesn't exist. So the limit doesn't exist in either of those two. For part B, this was the function. Again, if you set that denominator equal to 0, you'll find that x equals negative 5. That's the value that's going to make you divide by 0. You can't do that, so we have a discontinuity. To find that limit, we just factor the numerator and find that these two terms are going to cancel. And then what's left over is just the x minus 5. And if I take the minus 5 and plug it in there, minus 5 is minus 10. So that's the limit. For problem number 3, we had this piecewise function. I didn't write it down, but you should have it on your worksheet there. When you graph it, you should find that it kind of looks like this. To the left of 1, it's this linear function. Between 1 and 4, it's constantly 0. And then when it's greater than 4, it's this other linear function here. So we see that I would never have to pick up the marker until right here at x equals 4. That's the discontinuity. I'm asked to find the limit as x approaches 4 from the left. So if I'm coming in from the left, the function is constantly 0, so the limit is 0. If I'm coming in from the right, then I'm looking at that part of the function. What y value is the function approaching? It seems to be approaching that y value where the hole is. So that's the limit. The limit is 2 as I approach from the right. So that's it. If you have other questions about this problem, ask your instructor via office hours, me, or whoever your instructor happens to be.